Okay, 7-6, we're solving right triangles. What that means is to find everything. So whatever's missing, you find all the angles and all the sides. So in order to do that, we have a new idea for today, and that's this inverse sine, inverse cosine, and inverse tangent. Now, to make this make sense, kind of going back to our previous discussions, previously I told you that our formula looks like this. The sine of angle A is opposite over hypotenuse. This formula is used to find one of these two missing sides, either the opposite or the hypotenuse when the angle is given. So this is the only used for sides. I told you guys that these two pieces, the sine and angle A, can't be separated, and that's still true. But in order to pull out the measurement of that angle, we're going to do an inverse. So remember, when you solve your equations, multiplying and dividing your opposites, adding and subtracting your opposites, squaring and square rooting your opposites. Well, in this case, the sine and the inverse sine are opposites. That's how you get that angle by itself. These are still the same. These relationships are still the same. Sine is still opposite over hypotenuse, cosine is still adjacent over hypotenuse, and tangent is still opposite over adjacent. The difference is this inverse function. The only time you use the inverse function is to find the measurement of an angle. And anytime you're using these formulas, remember, you're not using the 90 degrees, you're using one of the acute angles. Okay, so it's the same formulas. What you need to know today is that inverse means you're finding an angle. Okay, let's look at our first example. With these kinds of problems, it's important to show your work. If you do your problem, let's say with Pythagorean theorem, and I did my problem with tangent, neither one is wrong. However, yours might be off by a little bit because we use different functions. So as long as you show your work, you could still get the same correct answer. Okay? So I'm going to use my trig functions in this one. It's not the only way to do it, but we're going to practice our trig because that's what we're learning. So I know that you guys would probably just subtract 90 and 37 from 180 and figure that out. There's nothing wrong with that. But we're going to practice our new ideas. So how can I figure out this measurement of this angle? Can we start with that? Let's think about this angle. Could we use tangent? The tangent of this angle, we don't know the angle, we don't know this side, and we don't know this side. We have three unknowns in that case. That's not a good starting point. You can only have one unknown. What if we do sine? The sine of this angle is opposite over hypotenuse. Can't do that either. We have two unknowns. Following me? What if I did cosine? Cosine of this angle, adjacent over hypotenuse. We still have two unknowns. So that's not a good starting point if we're sticking with our trig ideas. Let's find QR first. So what relationship can I do to use this angle, find QR, and use this side? What relationship is that? Yes? Tangent. No, tangent would be this one and this one. Because remember, this is hypotenuse. If you're getting confused with hypotenuse, which happens quite a bit, I would label it as hypotenuse. That way you don't make mistakes with it. What relationship? Cosine. It's cosine. So cosine of 37, adjacent is QR, hypotenuse is 22. This is an okay place to start because I know the angle, I know one side, there is only one unknown, which is a good place to start. This is what we already did. The hardest part about this is figuring out which function to use and what to plug in where. So you should know how to solve this already. So on your calculators, if you don't have Desmos open, have that open for me. I need the cosine of 37 times 22. What do we get?
17.6.
Good. So QR is 17.6. We're always going to round to the tenths place just to stay consistent. Now that I know this is 17.6, I can use it in my next step. Now let's go back to finding angle P. Do we have enough information to work backwards? To use one of these new fancy formulas? What formula would you use? So we're finding this angle. In relation to this angle, which side is this called? What is it? We have opposite and we have hypotenuse. So what relationship is that? Sine. So this is what's new today. I'm going to look for this angle. As soon as I'm looking for an angle, I know it's an inverse function. So I'm going to say it's a inverse of sine. That's what that -1 means. And I'm looking for angle P. So this relationship inside those parentheses is 17.6 over 22. The result of that will give me the measurement of angle P. So look how I did this. This was my formula up here. Opposite over hypotenuse. Inverse sine of opposite over hypotenuse will give me this measurement of this angle. So that's what I did over here. Opposite over hypotenuse will give me angle P. Does that make sense? Okay, on your calculators, I don't know if I have this up in mine, I don't. Give me 1 second, I have to change my computer. So on your calculators, on your Desmos, make sure that it's in degrees. We talked about that already. To get to your functions, you go to that calculator in the corner. Remember that? So in that calculator in the corner, you're going to select functions, and you're going to select the inverse sine. Remember how I showed you guys how to do this? So far we've been using that first column, sine, cosine, tangent. Now we're going to go to that second column. These are our inverse functions. So what we just wrote was inverse sine of 17.6 divided by 22. So that angle measurement is 53.1. Does that make sense? Try that on yours and make sure you're able to get that. So the measurement of angle P is 53.1. Question. So we have one more side to find. Yes, I know you guys can use the Pythagorean theorem. I don't have a problem with that, but we're going to practice our trig formulas because it's good practice for you. So let's use our 53.1. What relationship or what ratio can we use with this angle to find this side? You have a couple of choices. What'd you do?
Cosine.
Cosine would work. So cosine of 53.1 is adjacent, which is PQ, over hypotenuse, which is 22. So we're flipping back and forth. The last problem we were looking for angle. This one we're looking for a side. So of course we're going to do cosine of 53.1 times 22. Can someone do that on your calculator for me? Figure out what PQ is. Who's got it for me? 13.2. Thank you. So mark up your diagram. Make sure that you show work and highlight your answers. So here's my 3 answers for my unknowns to solve this right triangle. Yes? I knew you were going to ask me that. Yes and no. So if you subtracted, and this is a good example, if you subtracted from 180, you would have gotten 53, right? I did it in a different way. Because these numbers are rounded, that's throwing this off by a little bit. So because we're not using accurate side length numbers and we rounded, that's what throws it off. But because I'm showing my work for 53.1 over here, it is a valid answer. So I know where you're coming from with that. Any other questions for this one? Okay, let's do one more. So for this one, I want to start off by finding angle measurements because there's not a whole lot given to me. I have an unknown side and I have 2 unknown angles. I want to find angle P. What formula am I going to use to find angle P? Inverse sine, inverse cosine, or inverse tangent? It's definitely tangent. So let's set this up with our inverse. So inverse tangent, we're looking for P. So that relationship is opposite over adjacent, and that will give me the measurement of angle P. It's inverse because we're looking for a measurement of an angle. So plug that into your Desmos for me. Make sure it's an inverse, not just a regular tangent. And what's the measurement of that angle? 58.6, thank you. Let's find n. What formula can help me find the measurement of angle n? Inverse tangent. So inverse tangent of angle n, opposite over adjacent. This one's 11 over 18, and that will give me the measurement of angle n. Can someone do that for me, please?
31.4.
Good job. And again, there's nothing wrong with using the Pythagorean theorem, but we're using our trig formulas to practice it. So you have lots of options here. You can use one of these angles and one of these sides to figure out that hypotenuse. Sine or cosine, which one's your favorite? Sine it is. So you want to do sine of 58.6 or sine of 31.4?
58.
Okay, so we'll do sine of 58.6, which is opposite 18 over hypotenuse, which is Pn. These are the kinds of problems that you have to create your proportion out of. There's a dot there. We're going to create a proportion. So Pn times 58.6 equals 18. Should be parentheses there. Divide by 58.6. I did put a sign in there. Divide by the sine of 58.6. So this is what goes in your calculator, 18 divided by 58.6, sine of 58.6. I don't know why I keep leaving that off. Does anybody have that for me? 21.1. Thank you. So this side is 21.1. Okay, before I move on, solving a right triangle, is there any questions on this? So you have lots of choices and lots of options. As long as you show your work, you can use however you would like to find everything in that triangle. Okay, moving on to the next section here. The directions say, let angle A be an acute angle. So when you look at a right triangle, you have a right angle and you have two acute angles. Those directions are telling you that angle is one of these two. It says find the measure of angle A to the nearest tenth. Well, it shouldn't be a surprise. We're using our inverse functions that we learned today. And anytime you're asked to find the measure of an angle with trig, you're using your inverse functions that we talked about. So what I want you to understand is what's given to you. This says the sine of angle A is 0.36. This is very similar to, I'm going to find one that I did this with. I think I already erased it. I think I did. So let me just reset this up. If I did, to find this one, I think I did it this way. Tangent of -1, or inverse tangent, is 11 over 18, and that gives me the measurement of angle n. This right here is very similar to what we have here. The only difference is instead of a fraction, they're giving you a decimal. So they're telling you that relationship, that in this case it's opposite over hypotenuse. They're telling you the opposite over the hypotenuse divided gives me 0.36. We're going to use our inverse to figure out that measure angle. So these problems are actually easier than these problems. They already picked the ratio for you. You just have to use the inverse to work backwards. So let's set this up then. So this is an inverse sine, because that's what they tell us. And we already know the relationship is 0.36. I'm not needed to be given those two side lines. They already divided them out and got 0.36. The result of this will give me the measurement of angle A. Very similar to what we set up with example 1 and 2. So on your calculator's inverse sine of 0.36, what's the measurement of angle A? (21.1 degrees), and we're going to round to the nearest tenth. Look at the next one, similar kind of problem. They're already telling you, because we know tangent is opposite over adjacent, They already divided those out, and they got 0.8. So we're gonna use our inverse function to figure out what that is. So inverse tangent of 0.8 will give me the measurement of angle A. So in your calculators, I need an inverse tangent of 0.8. That'll give me that angle measurement. What'd you get?
36.7.
Good.
Oh, wait, no, 38.7.
Can someone just verify that for me?
Yeah,
38.7, thank you. I'm going quickly through these. Is there questions on them? Last one. Same kind of idea here. Cosine of angle A is 0.35, so in order to find that angle measurement, we're using our inverse. When I use my inverse cosine, my result, I'm going to find the measurement of angle A. So inverse cosine of 0.35. Does anybody have that measurement for me? 69.5. Thank you. So measurement of angle A, 69.5 degrees. Before I move on to my application, is there any questions? Okay. So this is a good application, and there is so many applications of trig now that you guys know it. This is talking about uniform accessibility standards with wheelchair ramps. It's important that wheelchair ramps are regulated so that we make sure that somebody in a wheelchair is able to get into a building. So the standard says that the ramp must be less than or equal to 4.78 degrees. We need to know if this wheelchair ramp meets that standard. So what we're talking about is this angle right here has to be less than or equal to 4.78 degrees. Well, we don't know what this angle is, but we learned a new thing today that'll help me figure out that angle, right? This is going to be an inverse function. So the first thing that stands out to me is that we have 16 feet and 14 inches. Change this to inches for me. What's 16 feet as inches?
192.
Got it. So changing feet to inches, we multiply by 12. 16 times 12 is 192 inches. So going up this wheelchair ramp, it's 192 inches this way, and it's 14 inches off the ground. What function are we going to use to figure out this angle measurement? What inverse function, I should say?
Sine.
It's sine. Because sine is opposite over hypotenuse, I'm going to label this as A to keep things simple. So I'm going to do inverse of sine. This is the angle I'm looking for. Opposite over hypotenuse. And that result will give me the measurement of angle A. So when you put this in your calculator, that's rounded 2 decimal places because that's what this one is. What do we get when we do that inverse sine? Anybody have that for me?
4.18.
So 4.18 degrees. So is this wheelchair ramp with an angle of 4.18 degrees in compliance with this standard? Because it says less than or equal to. So yes, it does work.